g. Total time t of flight is given by capital T equals to 2u sin theta all over g, which is our equation 4. And it is the time taken by the projectile to reach horizontal level. Again, the horizontal range r of the projectile is given by r equals to u squared cos theta times t. This is our equation 5, which is still equals to 2u squared sin theta cos theta over g. That is, range capital R is equals to u squared sin 2 theta all over g, equation 6. The range maximum capital R max is equals to u2 over g. Since 2 sin 2 theta is maximum when 2 theta is equals to 90 degrees or theta is equals to 45 degrees. Therefore, maximum range capital R occur when sin 2 theta is equals to 1 or theta is equals to 45. The maximum height is given by h, capital H equals to u sin theta times t minus half gt squared, equation 7. Putting t equals to u sin theta all over g, we obtain that capital H is equals to, in bracket, u squared sin square theta all over 2g. This will now be our equation 8. Example 1. A stone is shot out from catapult with an initial velocity of 30 meters per second at an elevation of 60 degrees. Find the A, time of the flight, B, maximum height attained, C, range. Take our force of gravity equals to 10 meters per second. Solution. Flight time, capital T, is equals to 2u sin theta over g, which is equals to 2 times 30 sin 60 degrees all over 10, which will give us 5.2 seconds. B, maximum height h is equals to a open bracket u squared sin square theta all over 2g, which is equal to, in bracket, 30 squared sin square 60 degrees all over 2 times 10, which will now give us 33.37 meters. C, the range R is equals to u squared sin 2 theta over g, which is now equals to 30 squared sin 120 degrees all over 10, will give us, in bracket, 30 squared sin 60 degrees all over 10, which now our range capital R is 77.9 meters. Example 2. A body is projected horizontally with a velocity of 80 meters per second from the top of a tower 100 meters above the ground. Find A, time of flight, and B, range. Take the gravitational constant equals to 10 meters per second squared. Looking at this diagram, assuming that the tower AB is 160 centimeter and the man projected at a speed of 80 meters per second from and it covered a range of BC, which is capital R. Solution. A, S is equals to UT plus half AT squared, which equals to minus 160, which is equals to 0 minus half 10 squared. Minus 160 is equals to 5t squared. T squared is equals to 160 over 5, which is 32 seconds. Therefore, T is this, making T the subject of the formula, and the square root will now cross over to become the square root of 32, which will give us 5.65 seconds. Therefore, the flight time, capital T, is equal to 5.7 seconds. Range R is equal to velocity u cos theta times time, capital T. Here, theta is equal to 0 degrees and cos theta is equal to 1. Therefore, range is equal to u times capital T, which is equal to 80 times 5.7, which is equal to 456 meters. Example 3. From the top of a cliff 80 meters high, a stone is projected horizontally with a tip of 20 meters per second. How far from the foot to the cliff and with what speed do the stones strike the ground? Take acceleration due to gravity equal to 10 meters per second squared. Solution. Horizontal velocity of projection u equals to 20 meters per second. Height of cliff h equals to 80 meters. Duration of flight capital T equals to square root of 2 capital H over G. Horizontal range of projectile R is equals to u capital T, which is equal to u square root of 2H all over G, which is equal to 20 times square root of 2 times 80 all over 10, which is equal to 80 meters. Speed at impact V equals to square root of in bracket u squared plus g squared capital T squared closing bracket, which is also equals to square root in bracket u squared plus 2g capital H, which will now give us square root of in bracket 20 squared plus 2 times 10 times 8, which is now 44.72 meters per second. We are now in equilibrium of forces. Moments. Parallel forces. Definition. The moment of a force about a point or axis is the turning effect produced by a force about a point or an axis, and it is measured by force times perpendicular distance from the point or axis to the line of action of force. Unit is a Newton meter. Principles of moment. For a body in equilibrium with some turning force acting, sum of clockwise moment about any point equal to sum of anticlockwise moment about the same point, or the algebraic sum of all moments about any given point is 0 for a number of coplanar parallel force acting on the body in equilibrium. Statics. Statics is where there is system of force without motion. Force that produce acceleration is resultant force. Moment of forces. Moment is the turning effect of the force. It is the produce of force and the perpendicular distance in straight line from the turning point. For a body hanging in a balance at a distance of x and y, Fn times x is equal to Fm times y. The line of every force is the same. Sum of moment about a particular direction is equal to 0. That is, sigma mg is equal to 0. Sum of upward force must be equal to sum of downward force. That is, sigma fy is equal to sigma fy. Example 1. A meter rule is found to balance horizontally at 48 cm mark. When a body of mass 60 grams is suspended at the 6 cm, the balance point is found to be the 30 cm mark. Calculate the mass